Hello everyone, I'm Russ Lowenthal, Product Manager for Database Security here at Oracle, and today we're going to talk a little bit about ransomware. And you may ask, well, what is ransomware? Ransomware is basically software. It is malicious software that is designed to invade your network and invade your systems, database systems, file servers, PCs, laptops, you name it. Invade your systems and deny you access to those systems until you pay the attackers a ransom. Normally, ransomware operates by encrypting the data on the systems it invades and simply withholding the key you need to decrypt that data until the ransom is paid. You may ask, well, how big of a problem is ransomware? There's a good chance you picked this session to attend because you already know it's a big problem, but just in case you didn't, ransomware is, by almost anyone's estimate, the number one by a mile issue facing security professionals today. It has eclipsed email threats, threats against data, accidental, everything. Ransomware is the biggest scourge on our industry in existence right now. Ransomware losses this year have already exceeded the ransomware losses in 2018, 2019, and 2020 combined. That's a huge growth model. Now, we don't have the final figures for 2021 yet. Obviously, 2021 is still in progress. But we know that in 2020, ransomware cost over $412 million just in ransomware payments. And that's a low-end figure because that $412 million is arrived at by blockchain analysis, where we're analyzing the blockchains of known criminals. So, $412 million, that is probably half of what it actually was. Well, again, we've grown this year. It's going to be bigger this year. Now, as a result of the growth in ransomware, and the growth in ransomware payments and the damage that ransomware incurs for businesses that are hit by it, we are starting to see it become more and more difficult to insure against ransomware. Many cyber insurance companies have simply dropped out of covering ransomware altogether. For those that continue to cover ransomware, they are taking a two-pronged approach. They are requiring increased protection to reduce your losses and your chances of ransomware hurting you. Things like encrypting your data, things like multi-factor authentication. Ransomware insurers are also increasing their premiums. At a minimum this year, premiums have gone up 90%, and in many cases by as much as 200%, especially for businesses that are heavily data-driven or with large, complex IT systems. And this trend is expected to continue as we move into 2022. It's getting harder to get insurance, it's getting more expensive to pay for insurance, and the requirements to continue to be insured continue to grow. How does ransomware spread? Well, ransomware, it's just malware. Well, it's not just malware. It's malware with a really evil purpose to it. But it spreads the same way that malware has always spread. Phishing attacks, open remote desktops, compromised systems, people reusing passwords. It spreads the way malware has always spread. But what's different is that ransomware attacks are big business. There is ransomware as a service. You don't have to write your own malware. You can lease somebody else's malware. You don't have to develop your own botnets to spread it. You can lease a botnet. This is big business. Ransomware attacks are very seldom targeted. It's not like someone is coming after you personally. They are looking for anybody they can affect because this is how they're making their money. Ransomware attacks are high-value, high-volume attacks that are usually very automated. It's a sophisticated set of software and specifically designed to elicit a ransom from you. They're designed to make you want to pay the ransom. Ransomware attacks will look something like this. Now, remember again, we're talking about an attack with a lot of infrastructure behind it. Huge botnets, very automated, malware as a service. But here's kind of how things get started. Somebody decides they're going to get into the ransomware business. And so they set up their command and control centers. They decide what malware version they're going to use. They decide what botnet they're going to use. Are they going to build their own? Are they going to lease somebody else's? But they get all the preparatory work done. Think of an internet startup. You're not too far off. Now, our attackers begin to go out and try and penetrate different companies, different organizations. They do this through phishing. They do this through fake advertising, by setting up websites that make people want to come to them, by sending out fake software upgrades. But they begin to get their malware out into the web. They infect somebody within your network. One person is all it takes. That one person clicks a link they shouldn't have clicked in an email. They open an attachment they shouldn't have opened. They do something that allows the malware to gain a foothold inside your network. And now we're inside the network and we're just sitting there very quiet. We're mapping out your network. We're gathering data. We're trying to learn as much as we can before we begin to do anything. During this period, we are harvesting credentials, local user credentials, domain admin credentials, network credentials, database administrator credentials, system administrator credentials. We're getting as much data as we can. We are surveilling your network, trying to map out where everything is. Where are your high-value systems? Where are your database servers? Where are your backup servers? Where are your storage arrays? Where are your file share servers at? Where are your domain controllers? I want to get everything I can so that I know as much about your network as possible. And now that I've got my information, I've mapped out my attack, I've got my battle plan in progress, I begin to execute. The ransomware attackers move laterally. They begin placing their malware payloads on every single accessible server, on every single accessible network segment, spreading as much as they can to infect as many systems as possible so that they can effect the maximum amount of damage. During this time, we particularly pay attention to backups, because we don't want you to be able to restore from backup. We want you to pay the ransom. So we go after your backups. We want to make it less likely you can successfully restore. We may begin to subtly corrupt backups. We may change backup schedules, but we try to do this quietly so that no one notices. As we're moving laterally, we scrape data off of the systems we infect. We take this data and we exfiltrate it outside of your network to our command and control systems. This is valuable data. This is the same data theft business that has always been out there. It's just with a new, slightly different flavor to it. Finally, the big day has come. We're now going to begin to make ourselves known, but we don't want to do this while you're there. So we wait until a long weekend. We wait until everything's quiet. And we know when things are going to be quiet because we've been on your network for a long time. We really know what's going on in your organization. We pull the trigger and we start to encrypt your systems. Every system, encrypt, encrypt, encrypt. And we are just chugging through. And it's a long weekend. You leave on one day, you come back 1, 2, 3 days later, and everything is encrypted, and now it's time for you to pay the piper. And so when you open up your laptop, when you access your remote desktop, when you look at your screens, instead of seeing what you normally see, you see something that says, hey, give us money, and you'll get your data back. That screen's going to look a little bit like this. It's basically going to tell you your storage has been compromised, we have your files, You have this long to pay us. Here is how much we want. Here is how you're going to pay us. And if you don't pay us, we are not going to give you your decryption key back, and we are going to release your files or sell your data. All right. Well, you're obviously a little concerned when you see this screen. What are you going to do? What do you do if you're attacked? And you should be thinking about this in advance. You should have a game plan laid out, but now it's time to make that decision. And you really only have two choices, right? There's only two ways you can go here. You can either pay the ransom or not pay the ransom. If you pay the ransom, there is a very good chance that the attackers are going to give you the decryption keys so that you can restore your systems and you can continue operations until the next time you're attacked. Remember, they know you'll pay now, so there will be a next time. You don't always get the key, right? Not every thief is an honest thief. Sometimes you pay the money and you don't get your key back. Sometimes it's not even that the thieves are dishonest. It is that something went wrong and they don't have your key to give you. But in about 5% of cases, you don't get your key back. If you do pay your money, there is a chance, a small chance, but a chance that law enforcement can get some of that back. It's happened in a couple of cases. It's so rare that it makes the news when it happens, but it does sometimes happen. Let's suppose you choose to pay the ransom and don't get the decryption key, or more likely, you just choose not to pay the ransom. Well, in that case, you are in a disaster recovery scenario. Large chunks of your IT infrastructure have been taken down, and you need to rebuild those systems from backups. But remember, during our attack, the attackers targeted our backup systems. So how do you protect yourself? I wish that I could tell you that you would come to Oracle and we have the magic thing that is going to keep a ransomware attack from ever targeting you, from ever infecting a single system in your organization. That's not the case. In the first place, Oracle is really not the people. We're not the company you come to for malware prevention or for antivirus. That's not our core business. That's not what we do. But what we do, what Oracle is really good at, what we've got decades of experience at, is when you decide not to pay the ransom, or when you pay the ransom and don't get your decryption key, when you're in that disaster recovery scenario, Oracle is really, really good at making sure you can recover your data. That's what we're about. We're the data company. So, how can you protect yourself? Well, from our point of view, the best way to protect yourself is to have a backup that can't be destroyed or corrupted by the malware. You want to have an immutable offline backup. Immutable, can't be changed, so this is like a write once, read many times backup. Offline, not on your network where the malware can attack it. Now, there's lots of different ways you can accomplish this. This can be something as low-tech and old-fashioned as magnetic tape. Those magnetic tapes that you've taken a backup on and you've got hanging there on your racks, in the event that you're still living in the days when you did mag tape, well, malware can't go out and infect those tapes. It can't change what's on those tapes. It can cause new backups to be corrupted, but your old backups are still going to be good. So one way is to simply have an offline backup on mag tape. Another way to approach this, a more modern way to approach this, is to place your backups somewhere that is not on your network. For example, a cloud backup service. That could be Oracle's cloud, it could be someone else's. But if your backup is up there in the cloud, not connected to your network, the malware that is racing through your network and infecting all of your servers isn't hitting that backup. Now, your best immutable offline backup is the Zero Data Loss Recovery Appliance. And the reason I say it's your best is the other two solutions, MagTape, a cloud backup or something like that, those are going to let you recover to the time when you did your backup. You're going to lose some data. With the Zero Data Loss Recovery Appliance, as the name implies, you're going to recover to the point of the last transaction. Zero Data Loss Recovery Appliance, we'll call it ZDLRA because that's just a little bit easier to work with. Zero Data Loss Recovery Appliance allows you to create immutable backups. You can set a minimum retention time for backups, and once set, you can never decrease this time. You can always say, I want to keep a backup longer, but you can't shrink it below the time when the backup was taken. During this time, the backup cannot be deleted, cannot be overwritten, regardless of who says to do it. It doesn't matter if it's the DBA saying to delete the backup. It doesn't matter if someone has compromised the recovery appliance administrator credentials. That backup is in the system and it can't be changed. All right? You can go even further. You can take your ZDLRA and you can add to that a recovery vault. This is a separate system on a completely different network that is not connected to your normal network, and where from your operational network you cannot make a connection to this recovery vault network. Periodically, the recovery vault will initiate a connection back into your operational network and will replicate data from your ZDLRA to the offline replica ZDLRA and then reestablish the air gap so that you've got your regular backups in your operational center and you have got your offline vaults. Belt and suspenders. You always want to make sure you can recover. So from the standpoint of what do you do if your data is destroyed, immutable offline backup is the best solution Oracle can recommend for you. Now, remember that the ransomware didn't just encrypt all of your data and deny you the keys. During the attack, the attackers were also exfiltrating data. They were taking data from your network and moving that to their command and control centers. Most ransomware does this now, and during the attack or after the attack, this data that has been stolen is used to try and influence you to pay the ransom. That threat that if you don't pay the ransom, we are going to leak your data. We are going to sell your data. At this point, your problem has become a traditional data breach. Someone has stolen your data and they're going to sell it and use it against you. Your defense here is one that you're hopefully already doing. Hopefully you're already doing this and you don't even have to worry about this part of it. But from a database standpoint, the defense against exfiltration and extortion is to encrypt the data. Because if your database is encrypted and the thieves get on and they steal your databases out from under you, well then, just like you can't read your data if they encrypt it, they can't read your data if you've already encrypted it. Please don't misunderstand me. Encrypting your data, using transparent data encryption to encrypt your database, doesn't stop the ransomware from encrypting it again. It just means that if they steal the data, they can't read the data. So, encrypt your databases, protect yourself against data exfiltration and extortion. But keep in mind, if I steal your data, your encrypted data, and I also am able to steal the encryption key, it's like your data wasn't encrypted at all. I can just decrypt it. So when you encrypt your data, make sure that your encryption keys are not stored on the database server. They need to be stored somewhere else in a protected area. At Oracle, we call that our key vault. You place your database encryption keys in the key vault, which can't be broken into. It's a hardened appliance with very little threat surface. And the database is able to retrieve the keys, but not destroy the keys, not overwrite the keys. Okay? So this is how we protect against exfiltration and extortion. But there's more you can do. All right? Database Vault can help protect against a ransomware attack by isolating data from privileged accounts so that if the attackers during the credential harvesting phase manage to get DBA accounts and log into your database and begin trying to steal data that way, they can't do that because the DBAs can't see the data. That's what Database Vault does. Database Vault can also be used to help your database block attempts to use it to spread malware. Databases often link to other databases, and it's theoretically possible for malware to travel through those channels. Another thing you can do to protect your database environment is to make sure that it is configured in a secure fashion. You can use things like the Database Security Assessment Tool or Oracle DataSafe to help identify configuration problems that might be used to try and gain access to your system. Yet another thing you can do is make sure you are monitoring your database activity. If you see someone probing your database, if you see IP addresses talking to the database that have never talked to it before, or programs that you've never noticed on your network before, Audit Vault and Database Firewall can point that out to you. It can alert when it sees these anomalies and allow you to take proactive action, possibly stopping an attack. That's rare, but hopefully reducing the time during which the attack is going to be able to steal data. There's still more you can do to help improve your odds of surviving a ransomware attack. Malware frequently spreads through system vulnerabilities that are already known but just not patched yet. So shortening your patching cycle can reduce your risks of your risk exposure to ransomware. Consider using something like the Autonomous Database, where patches are applied very frequently. Normally Oracle releases security patches once a quarter, and you get those patches and you patch them again, and it's a real pain, but every quarter we release patches. Autonomous Database patches frequently, weekly, every other week. It is as soon as we identify something, as we're building up those big security patches that we release quarterly, Autonomous gets those way, way in advance of everything else. This next one's going to sound maybe a little controversial, and don't get me wrong, no one operating system is proof against ransomware. But statistics, numbers, tell you that most ransomware attacks target Windows. So if you can, run your database on something other than Windows. This doesn't guarantee ransomware is not going to hit you. There's nothing inherently better about Linux or Unix that's going to stop a ransomware attack, but again, it's a numbers game. It's a business. Most malware targets Windows. Run your databases on something else. Ransomware spreads over your network and many times does not cross data center boundaries. So if you have multiple data centers, consider placing a DataGuard standby database in another data center. There's no guarantee that's going to protect you against ransomware, but it does give you one more little bit of mitigation of risk. And finally, most ransomware attacks the file system. If you have your databases running using Automated Storage Management, ASM, ASM is a raw file system. It doesn't present the same way that most ransomware does. It's not easy to just pull the files off of ASM. So you may find that malware can't locate those files and pull those out. And that again will give you some protection against ransomware. All right, we've talked about a lot of things, but the funny thing is we've barely scratched the surface when it comes to database security. There is so much more to learn. If you would like to know more about database security, there's a couple of resources I want to make you aware of. One of those is the book Securing the Oracle Database. My team produces this book. We're on our 4th edition right now. Go to oracle.com/securing the database. It's just an electronic book. The first edition was really short. It was about 60 pages. By now, we're up to around 150 pages or so, but it's not a really tough read. Most months, we do office hours. The second Wednesday of the month, and we hold 2 sessions, one at 9 a.m. U.S. Central Time, the other at 6 p.m. U.S. Central Time. Content is identical. We'll cover some technical topic. We'll make any announcements about new patches, new issues, new features that have come out. But we do this every month. Please join us, bit.ly/AskTomDBSec to subscribe to it. And these sessions are recorded, and the recordings are all also available on that website. And then the final resource I want to make you aware of, and one of my absolute favorites, is Oracle Live Labs. Oracle Live Labs uses our cloud to give you hands-on experience in a realistic-looking environment where you have a database to play with. There's sometimes an application, there's sample data sets, but you can play around with the different database security features and options so that you learn your lessons in a guided path at your own pace without ever having to leave your desk. All right, so Oracle Live Labs. Go to bit.ly/GoLiveLabsDBSec to see the database security labs. That's it. Thank you for giving me some of your time today. Again, we've talked about ransomware. We've talked about the importance of protecting yourself against ransomware with an immutable offline backup. And we covered several different strategies for that. And we've talked about why it's so important to encrypt your data at rest and in motion to protect yourself against data theft during a ransomware attack. Thanks again for giving me some of your time today. I hope to see you again.